Then from the point C, extend this line till some point. Let's call that C prime, for which this and this be equal. For instance, suppose you came to here, and this was 10 meters, and you go another 10 meters in the same direction till you and mark down the point C prime, and then with another chain or with the same chain, you starting from here, you go till you reach to C, and again extend it as much as this one, so these two are equal. Call it B prime. And now we got here two triangles, this and this, in which two sides are equal. This is equal to this, this is to this, and the angles included are also equal, because we talked about that before. We got two intersecting lines. This angle should be equal to this. So the two triangles are congruent. Then the corresponding seams are equal. What is the and this angle is correspond to this side, which we want to find, and this angle corresponds to this side. Okay, then AB equals to B prime C prime. So instead of measuring this directly, we measure the distance from B prime to C prime. Let's have another example. Let's prove a theorem which says in every rectangles a rectangle got four sides, in which this equals to this and this equals to this, and all of the angles are right angles. Okay, and the theorem says in every rectangles the diagonals are equal. This is A, B, C, D. It says that I should have drawn it straight. Let's draw it straight. Okay, it says that AC equals to BD. Okay, let's prove it. But how? Okay, when it was required to prove that two lengths are equal, one way is using congruent triangle. So we should find two triangles, two congruent triangles, one side of which be AC and one side of another triangle be BD. So how about these two triangles? ABD, this, and ABC. Let's show it by another color. Okay, this and this. Okay, now AD equals to BC because it is a rectangle, and AB is common between two triangles. AB equals to itself. Okay, and this angle equals to this angle, or say A equals to B. Then, according to the rule, two sides and the angle between or included angle are equal, then the two triangles are congruent, then the corresponding things should be equal, and AC is corresponding to this angle and BD is corresponding to the equal angle, then AC should be equal to B. And the second rule for congruency of triangles is that if the sides of two triangles be equal to each other, then the two triangles are congruent. Which means that if this side be equal to this side, this be equal to this, and this be equal to this, then the two triangles are congruent. And you know, these are, I mean, somebody over these 4,000 of years proved it already, and also the previous tool. But you know, I prefer not to talk about the proof right now, but later I make some video on that and put it below this video in the geometry playlist. Okay, let's not worry about that right now. So let's see how it helps us. Here I want to tell you how could we bisect a given angle. O is called the vertex O, and A is some point on this, and B another point on this. You see, it's, you know, one way is measuring the angle using the protractor, and then calculate and or divide it by 2. And bisecting means that dividing it into 2 angles with equal magnitudes. Okay, so we could first measure this angle and divide it by 2, and then whatever the result would be, mark the number on this and join the point to O. So okay, but again this thing got errors, first in measuring the angle, then in marking the half of it, because as you may see here, it got 1 degree only. On its accuracy, it's 1 degree. And the angles are not that say integer. So another way is using this one. But how? Here I first give you the method, then I say why this is true. So we first put one leg here. Let me draw it on paper. Let's do it here. Okay, put one leg of the compass here at O and draw an arc. Okay, and arc means a piece of circle, a whole circle, and from the intersection points, let's call it C and this D, draw another arc, with the same radius or different radiuses. Same as the radius of this arc. Okay, so for instance, the arc from B is like this, and the arc from C is like this, and join the intersection points of these two to O and call it H, and OH is the bisector of AOB angle, OB. Okay, but why is this?